Educational Module. Machine Learning. Learning Unit. Advanced. MapReduce. Spark. And Hadoop. MapReduce is a programming model and an associated implementation for processing and generating big data sets with a parallel, distributed algorithm on a cluster. A MapReduce program is composed of a map procedure, which performs filtering and sorting, and a reduce method, which performs a summary. An example of the map procedure would be sorting students by first name into queues, one queue for each name, and an example of the reduce method would be counting the number of students in each queue, yielding name frequencies. Before MapReduce existed, using the traditional way of parallel and distributed processing, we would stumble upon certain issues when it comes to huge data sets. The main idea is to split the data into smaller parts or blocks and store them in different machines and then combine the results from each of the machines. Here are some challenges. If one machine faces delays, the whole work gets delays. Any of the machines working with a part of the data can fail. Reliability. How should the data be divided to perfectly utilize all machines and have each machine get an even part of the data? If any of the machine fails to provide the output, the result cannot be calculated. Fault tolerance. How should the results be aggregated? A MapReduce system utilizes distributed servers, running various tasks in parallel, managing all communications and data transfers between the various parts of the system, and providing for redundancy and fault tolerance. Why MapReduce? The key contributions of the MapReduce framework are not the actual map and reduce functions but the scalability and fault tolerance achieved for a variety of applications by optimizing the execution engine. Big gains in speed and performance can be seen when using MapReduce with multi-threading. It is inspired by the map and reduce functions commonly used in functional programming. A big variety of libraries have been written for MapReduce. The most popular implementation of MapReduce is Apache Hadoop. Overall, MapReduce is a framework for processing parallelizable problems across large datasets using a large number of computers, nodes, collectively referred to as a cluster, if all nodes are on the same local network and use similar hardware, or a grid, if the nodes are shared across geographically and administratively distributed systems, and use more heterogeneous hardware. Processing can occur on data stored in a file system, unstructured, or in a database, structured. MapReduce allows for distributed processing of the map and reduction operations. Maps can be performed in parallel, provided that each mapping operation is independent of the others. While running the reduction process in multiple instances can often appear inefficient compared to algorithms that are more sequential, MapReduce can be applied to significantly larger datasets compared to traditional methods. The parallelism also offers some possibility of recovering from partial failure of servers or storage during the operation. If one mapper or reducer fails, the work can be rescheduled, assuming the input data is still available. MapReduce's data locality. Another advantage of MapReduce is that instead of moving data to the processing unit, which in our case are a very large size dash, we are moving the processing unit to the data. This is very cost efficient while also reducing the processing time as all the nodes are working with their part of the data in parallel. The MapReduce frameworks allows for distributed parallel processing by first reading a block of data and producing key-value pairs the mapper. Then, they are given as input to the reducer, which receives the key-value pair from multiple mappers. Finally, the data tuples are aggregated into the final output. The 3 steps are the following. Step 1. Map. Each worker node applies the map function to the local data, and writes the output to a temporary storage. A master node ensures that only one copy of redundant input data is processed. Step 2. Shuffle. Worker nodes redistribute data based on the output keys, produced by the map function, such that all data belonging to one key is located on the same worker node. Step 3. Reduce. Worker nodes now process each group of output data, per key, in parallel. A simple example is presented below. It is on counting the appearance of words in documents. The overall MapReduce word count process is illustrated in the figure below. Apache Spark is an open-source distributed general-purpose cluster computing framework for real-time processing. It uses MapReduce, but only the idea of it, not the exact implementation. Its main feature is the in-memory data processing engine that can do ETL, analytics, machine learning and graph processing on large volumes of data at rest, batch processing, or in motion, streaming processing, with rich concise high-level APIs for the programming languages, Scala, Python, Java, R, and SQL. Overall, Spark provides an interface for programming entire clusters with implicit data parallelism and fault tolerance, a cluster computing engine. A good way to describe Spark would be a data processing engine for batch and streaming tasks with integration of SQL queries, graphs and machine learning. It features the ability to seamlessly integrate machine learning pipelines, graphs, streaming, all under a consistent API. SQL, mlib, and GraphX make it easy for data scientists to build advanced models and systems. It is worth noting that Spark is highly flexible, as it can be run both locally, in clusters, as well as the cloud. Recapping, Spark's main advantages are speed, ease of use, extensibility, and interactive analytics. Top-tier distributed batch data processing. As previously mentioned, it draws ideas out of MapReduce, but implemented in a better way. Extremely good API that enables unified development and supports a variety of programming languages, all in a single execution engine. High usage of memory and little to no usage of disk, leading to better performance. High performance, even higher than Hadoop, especially at low latency iterative workloads. Apache Hadoop is a collection of software that facilitate using a network of many computers to solve problems involving massive amounts of data and computation. It provides a software framework for distributed storage and processing of big data using the MapReduce programming model. In particular, The computation is performed across clusters of computers using simple programming models. It is considered the best framework for processing data in batches. According to its co-founders, the genesis of Hadoop was the Google File System paper that was published in October 2003. Subsequently, a year later, Google released another paper named MapReduce, Simplified Data Processing on Large Clusters. Development started on the Apache Nudge project, but was moved to the new Hadoop sub-project in January 2006. In January 2008, Hadoop was made its own top-level project at Apache. A computer cluster is a set of loosely or tightly connected computers that work together so that, in many respects, they can be viewed as a single system. Individual computers within a cluster are referred to as nodes. Hadoop is designed to scale out from a single server to thousands of machines.